anyone get away with that. But right now, I got to run and turn in my paperwork. Guys, keep it up. Thanks everybody for checking out the show, for being here. We've got John Sudlick is in the show. Ebon Kim is in the show. Pebble in the Pond. We've got Flat Earth Math Charles here, and as well Scott. Guys, thanks so much for being a part of the show and making it happen. I got to step away. I'll be right back.
All right. Well, yeah. Well, I was just saying, like, I don't believe that a landmass can be refracted up. But I have a question though. Okay, you can say lasers, you can say light, you can say things bend in a certain way at certain because of atmospheric conditions, right? What was your name again? I'm sorry.
It's Charles.
Charles, yeah, Charles. Yeah. I know that light can bend. Can seem visually like it's not bending, but it's visually looking like it's bending. But let me ask you a question. Above all that, because you guys are talking about buildings and how you know what a plumb bob is, right?
Yes.
A plumb, like when you build a building. Because I've built buildings and stuff like that, and I know what a plumb bob how it works, right? It will go down to the radius, like to the. I mean, sorry, it would go down to what you would call the radius of the ball that you think that you live on, right?
It just points straight down. We'll just
perpendicular.
Yeah,
perpendicular.
Perfectly
it goes
vertical.
perpendicular to the ground, right?
Right.
Okay. So I've always thought about this, like, because you know how there are ways of measuring distances, right, at long distances, right?
Yes.
Okay. So let's say we had a Sears Tower, just as hypothetical, but it's very possible you could do this. You have a Sears Tower next to a Sears Tower that is 5 miles away, right? Let's just go 5 miles, right?
Yes.
And you measure the distance between the bottom of the Sears Tower, the first one, to the bottom of the one that's 5 miles away, and then you measure the bottom of the top of the Sears Tower to the other one, right? Do you think that those would be different?
Yes.
So you think that's have you ever seen that proven?
No, because it's a ridiculous it's a ridiculous
is that
thing.
ridiculous?
It would take, yeah.
Is it ridiculous?
But
no, it's not though.
No. It's a good question.
They have things that can measure. There's ways of measuring distances.
Yes.
Right? And then so if you have 1,000-foot tall building, the top of that building, I can almost guarantee you, I can't guarantee it, but I can tell you they wouldn't work because like you guys are talking about like the leaning thing, it wouldn't work, dude.
The lean away.
Well,
but then the question is, how much distance would you expect if the Earth were a globe?
That's the question. Well, according to the mathematics of the spherical equation, it would be, and of course, it would at a 5 mile distance, it would be very small. But you can measure things at very small rates. So at very small,
A theory.
We have like a Leaning Tower of Pisa situation.
That would be a very small amount. You have these two towers 5 miles apart, and they're
of course 5 miles is not very far.
Right. But they're quote unquote leaning away at the top.
Yeah.
By how much? A couple millimeters? An inch? Who's going to notice that the tops are an inch apart? Well,
who's going to notice? You know how there's very minute dude, there's ways of doing that.
Oh, sure. And if you did it, it would be a very interesting experiment. I would love to see something like that. But that's not with I lead with when I'm trying to convince people, about the shape of the Earth. I don't lead. I don't lead.
I don't know your background. Are you trying to convince people that we're on a globe? Is that
okay?
Because I'm not trying to convince anyone of anything. I'm just asking questions. By the way,
I would love for people to discover the truth of our world. Let's put it that way. And so, because my channel, not nothing, but it has a whole ton of DIY experiments. And I don't know if you heard my conversation with Travis. He's looking at the Belt of Orion. And
we were talking about that actually. Yeah, it's very intriguing, but I'm not sure exactly.
You just looked at the Belt of Orion, and like I said, it's December. Everyone should be able to see Orion. Orion's high in the sky in the winter, the winter sky. I don't know if you're in the northern hemisphere.
Yep.
Okay, so if you were to find when Orion is due south of you, and you were to measure the angle of elevation to Orion, that's going to match 90 degrees minus your latitude. I don't know what latitude you're in, but I just made a prediction. I don't know you. I don't know where you live.
Oh,
but
you're
I
saying
can tell
you're saying that no matter what, it'll be 90 degrees latitude from where you are, no matter what, right?
Minus your latitude. Is correct.
Yeah.
It's
Are you saying?
You know?
Are you saying that proves a? Are you Oh, you're saying that that somehow proves a globe? I mean,
No,
a
it's
globe thing?
consistent. It's consistent with a globe, and you cannot make the same measurement on a flat Earth because
I know what you're saying, by the way, because believe me, bro, I don't believe in the circle AE map thing.
okay,
I don't believe in that. As far as like, I haven't seen proof of it, right?
yeah.
But you can't throw. You can just. The thing is, though, I'm pretty sure. Can you prove that that an ocean curves? Can you prove that to me? That an ocean curves?
Well, my emphasis is on the shape of the Earth, and like once you figure out the shape of the Earth, well then you answered your own question. But water looks flat, you know. Water looks flat.
Yeah, water looks
and
flat because I'm pretty sure it is. You know what I mean?
well, but so
Pretty positive.
me arguing that this flat-looking water is actually curved, it's not going to convince anybody. So I don't lead with that either.
Hold on now. Hold on. I'm going to try to be as fair and equitable as possible, as well as trying to be ironic. But to be honest, Charles, you dodged that question.
Which question?
The one he just asked you.
Oh, about the water curving.
Can you
Yeah. Can you prove it?
prove it?
Yes.
Okay.
So, if you're familiar with the Bedford level experiment,
I've heard
No,
of it.
no,
That's the
sir.
level
Okay,
experiment.
hold on. Wait, hold on. Let me rephrase, or let me reiterate the question. Can you prove it?
it's logistically very, very hard. So, can I prove it like with my gear right now? No. But if you gave me a budget and we took a airplane trip to London or to England, we sat across the Bedford Level Canal, you'd be able to see the hump of the water very nicely.
So Rumpus
What?
is supposed to be doing this, right?
No, I'm not familiar with what Rumpus is doing.
Okay, yeah, we've been waiting for Rumpus to do this forever. So
Yeah, but
yeah, you know what?
it shows a hump in the middle. That's the thing. It shows the water
No,
has
it
a hump in the middle.
doesn't. No, it does not.
Well, then,
Wait,
then
was
you're
that the
not-
helicopter thing? That wasn't the helicopter thing, was it?
No.
No. He's
Okay.
talking about the 19th century wager for
With Alfred Wallace.
with
Alfred Wallace.
Wallace and Robotham and whatnot. But yeah.
Oh yeah, okay, yeah.
But with there was a banner, and then there was a pole that was like 14 feet above the water in the middle. So you had a pole 3 miles away, bridge 6 miles away, and then you hung this big black banner, a line. It's like a big horizontal line. And then they shot they had a theodolite type telescope. I guess it was like an auto level telescope. And they clearly saw that when they went from bridge to bridge, they saw that the post was higher in the middle, even though the canal was flat water the whole way. So that showed that it was at the ends. So
Really quick thought. I just realized that your name is Flat Earth Math.
yes,
Why is your name Flat Earth Math when you don't believe in a flat Earth?
because I participate very enthusiastically in the flat Earth debate.
Yeah, enthusiastically opposing it, right? Like
Well,
that's kind of
no. The thing,
weird.
The thing is, we're having a great conversation here. I would like for you to walk away from this conversation with a smile on your face and not feel that you were attacked. And what's on
I
your
will
channel-
totally walk away with a smile on my face, dude. I will, because I already had someone this whole time. Because I was like, are they splat smacking someone? But I just didn't know. But you sounded like I don't know, like in the chat, you sounded like I don't know. I get a weird vibe off you, brother. That's all.
Okay.
Sorry.
Well,
Here's my question to you. If it's 3 miles, 6 miles, say it's 3 miles
the
away.
level was 6 miles.
Okay, 6 miles. I mean, that's still 6 out of 60, 1/10 of a curvature. I mean, if you can't
like
see
a
the
degree.
lean away, you can't. Yeah, if you can't even see the lean away
Yeah.
in that same distance, then how can you see the curvature of water at that distance?
Yeah, well, you see the effect of curvature. You see the post. So, you have a 14-foot high banner, another 14-foot high banner. Those are your endpoints. And then you have a 14-foot high post with like a circular target that you plant that, in the canal. It's 14 feet end to end. The canal is flat, calm water, right? So you've got 3 14-foot tall references. If you take a telescope from one 14-foot tall reference and you aim it back at the other 14-foot tall reference, the post is sticking up 4 feet in the middle, right? You're not seeing like the curvature of the Earth, but you're seeing the effect of curvature. All right, the Earth is a big place, but you are seeing that middle post is going to stick up 4 feet. And so it's like, well, but all the posts were exactly 14 feet. How could one post be taller than the other two posts? And it's like, they're following the curvature of the Earth, which is not much.
This sounds as ridiculous as Travis said it would be.
Yeah, well, that's why I don't go with measurements that made at the ground, because it's like my eyelash example. Somebody drops an eyelash in your hand, they're like, weigh the eyelash, and you're like, it doesn't weigh anything. It's like how would you weigh something? How would you measure something that is close to zero, that you can't tell that it's not zero? So, but if you look at the sky, for example, Orion's belt. If you looked at Orion's belt and you went any latitude you want, northern hemisphere, southern hemisphere, you looked at Orion's belt, it's always going to be 90 minus your latitude, and that is absolutely impossible on any other shape of the Earth other than a curve.
So is it possible, Charles, that the effects of what you just described in terms of longitude and latitude, is it possible that that's created by the sky itself?
Yeah, and that was the focus of my video tonight, was that
natural
distortion.
Hold on. I'm sorry. I
Yes.
know that you're going. Okay, so yes, thank you. Yes,
Okay.
The answer is either yes or no.
Okay.
So just real quick, for everyone out there in the cheap seats as well, this wasn't said tonight, but it was said prior to this in other scenarios as well. If I asked you if you have stopped beating your wife yet, because no one has made the argument that I beat my wife, so you can't ask me if I've stopped. Also,
Right.
It's a non sequitur, because it has no place in this argument, because it's not a yes or no. Especially if I've never beaten my wife, I can't answer yes or no. It's I have never beaten my wife. Oh no, you have to answer yes or no. So it is a logical fallacy in argumentation to pose that question as a response to being asked a yes or no question without any rhetoric.
That's what I was just thinking,
Yep.
Travis. This is very weird. I was like, I was feeling like a straw man situation going on, and I was like, and you just you hit the nail on the head there, Travis.
Here's
So
here's what's confusing me is
Sure.
it's not an observation of curvature, but it's an effect of curvature.
Yes.
Is there a non-observation of something that's flat and an effect of something that's flat? That's what's confusing me. Is like, it's not an observation of curvature, it's an effect of curvature. So is there something that's opposite that you can point out that I can understand? What's an effect of something flat?
That's a great
not
question.
observably flat.
Yeah. Well,
Because-
but everything appears to be flat. So I don't know. I mean, it's just that when you go long distance, that's when you run into trouble. But everything appears to be flat. Water appears flat. Or kind of foundation flat. But that's a great question. I don't have an answer for you.
Hey,
But-
hold on just real quick. Sorry, I was on mute. I was trying to jump in. So everything does not look flat. Okay, that's a misnomer. That's a misspeak. Okay, we all know that the Earth is not flat. It has topography. Okay, so when you're standing out in the middle of the wilderness, it doesn't look flat.
Yeah.
Okay.
Yeah.
Now,
I was talking about calm water.
Okay, but still, that's still not the point. The point is that the elevation of the shoreline is equidistant all around.
Yes.
Yeah,
means-
that's a good question. Yeah.
Okay, which means that if we're on Lake Tahoe and Abon is out in the middle in his boat fly fishing, and I'm on the north side, and Charles is on the south side, and we've got John on the west side, and we've got Scott on the east side. And because Pebble in the pond is here, he's somewhere out there too. We don't know where. But if we all put our toes in the water at those 4 opposing cardinal directions, we are all at the same elevation, and we are all horizontal to one another. There's no question about that.
Exactly.
None whatsoever. We are all, in fact, horizontal to Ebon out in the middle of the water. He's not higher. He's not on a hump.
If we all had altimeters, right? If we all had our elevation, then we'd be equal elevation, but we still see each other equally level to each other. Therefore, it's level towards each other, right? You know, that's all I'm saying. That's how I see it.
And it doesn't, right, and it doesn't matter if I'm standing on the shore at my coordinate and someone is a quarter mile away from me and their feet are in the water and my feet are in the water, we're level. It goes that way all the way around this 22 by 11 mile lake.
The train a couple years ago, and when I was in the middle, the horizon had disappeared. The bridge just disappeared through the couple years.
And
it's level towards each other, right? You know, that's all I'm saying. That's how I see it. Elevation, but we still see each other equally level to each other. Therefore, it's level towards each other, right? You know, that's all I'm saying. That's how I see it.
And it doesn't, right, and it doesn't matter if I'm standing on the shore at my coordinate and someone is a quarter mile away from me and their feet are in the water and my feet are in the water, we're level. It goes that way all the way around this 22 by 11 mile lake.
The train a couple years ago, and